Alright, it's come to my attention that some of y'all haven't really figured out how to compute a point with the Trimble and also how to translate and rotate a job. So I downloaded this simulator and I guess I'm going to just kind of simulate it for you guys. So let's go ahead and start a brand new job. You start a job, we have our own naming system. For this one, we'll just call it test. So, whenever you start a new job, you have a template. We already have templates set up, so they should be in there. Most of them say LDG, which is my initials. US survey feet on this one. So, the chord system here, you can do so. Of course, if you're doing GPS, you would actually have to go in there and select all that, but we're not doing that right now. So this is actually something important in the units. Of course, you want to make sure it's US survey feet, but this little thingy right here, if you do not click it, you'll have to do all your calculations in azimuth, and that's annoying. So start that here, ignore all the rest for now, accept. So let's first start by entering in your first point. Do that, you want to go into key in points. And key in a point number 100 is what we always do our calculations in. You go down to northing, 5,000 over 5,000. You give it an elevation, and then you want to store this point. Now we got a starting point. So you go in the Cogo, compute points, and choose a method. We've got all kinds of different. You want to set up on a point, backside another point, go an angle. You'll want to do this one, turned angle and distance. Of course, you want to go bearing and distance. You want to click on this one. So, it kind of confuses. Usually, you enter something in and it puts the point you want to store on the bottom or after. But this is the point number you are going to store. So 101, and this is the code that you're going to store as well. So you can change your method again if you want to. Bearing and distance is what we're going to do this time. So you got to choose a starting point, which is where your calculations are going to come from. If you are going to stay in the same spot and calculate a bunch of points from 100, you'd choose radial. If you want it to traverse to point number 101 after you calculate it, you want to click on sequential. So start point 100, we'll give it a bearing, and right here you can enter in an azimuth. As you can see, 90.2525 would be like southeast, right? Or you can just hit 90 and then northeast. If you wanted to change it, 55 northeast. Let's go 90. And then down here at the bottom is your horizontal distance, which you're going to calculate it at, and we'll just do 100. Calculate. See, it automatically went to point number 101. Went ahead and went like you're going to calculate point number 102. It keeps all the bearings and the distances in here. We're just going to put a couple in. 102, and we'll do 3, 2, 3, and we'll do 4. So 1, 2, 3, 400 foot. I don't know what just happened there, but it went crazy. Alright. So we've got like our calculated points in, you know, you'd take a plat or something and you'd calculate all the property corners, you'd have your plot plan or your building, you know, already set out, or maybe you got a point, you know, file from the office or something, you got these in here already. Awesome. So what we want to do is we want to drive up to the job later and we want to just, you know, you'd go and find these property corners and we want to shoot them. So you got to have a new starting point and you want to have it in a different point range. Your calculation points you always want to have in a range, and then all of your other points you want to have in another range. It's just easier to calculate that way down the road. So we're gonna key in a point, call it point 1, or let's pretend like we just set up on a cap iron rod. How about that? I like to keep the coordinates kind of far away for this, just to kind of show some of the new guys how it goes. So you enter in point 1, store it. As you can see on the map, zoom to extents, point 1's just way over here, up in left field, right? So we can actually even pretend on here like we're setting up on this. So to do that, measure, I made a emulated thing like I'm setting up and shooting with a gun, but I'm just going to be typing in the angles and distances. You get a station set up just like you normally would. Normally, I think the pressure comes in by itself and you have to type in the temperature. So we want to set up on point number 1 and give it an instrument height if you want to, and if you're not using elevations you can just leave that. I'll even ask you, instrument height is null, is that okay? Yeah, it's fine. So now we're going to backcite point number 2. Let's just say we found an iron rod. Of course, your backside height. This is where Jay has been talking to some of y'all about this. This is going to be the bearing between your point number 1 and point number 2. If you're out in the field and from point 1 to 2 looks like it's straight to the east, you're going to want to put 90. And you can use this also if you want to, 90 northeast. So enter and pretend like right here this gun's actually measuring it itself. It'll set the angle to 0 and we'll just say it's like 100, even though we'd probably take the further back side if we're out in the field, but it doesn't matter when you're calculating. Alright, as we can see, it's not on here yet because you have to hit the store button.
Station setup completed.
I don't know if you guys knew this or not, but if you can like hold down on the little plus, you can actually zoom by a little box. You can make a box that'll zoom to that box. Alright. Measure topo. We're set up on 1, we're backsighted 2. And now we're going to shoot point number 3 in. Well, yeah, we'll just say it's an iron rod. Again, the gun will measure this. There we go, hit the button.
Observation stored.
There. And just enter in, we'll just pretend like we found some points and shot them in.
Observation stored.
And we'll do one more. Oh my god, I keep forgetting to put that in.
Observation stored.
Alright, so now we got some points over here that we shot with a gun, right? And we've got some points down here that we calculated. What we want to do is bring those points that we shot down here to these. The first step, the very first step, is to find out what points match with what points. To do that, you would go to Cogo, compute inverse. So now you can compute an inverse distance between these points. Let's just say the two furthest ones here was 100 and 104, right? 100, 104. 90 degrees, 400 feet. So 1 to 4, whoops, 300 feet. 1 to 5, 500 feet. So we don't have one that matches that, right? So we could try 100 to 103, see what that distance is, 300. That's pretty much what it is. You're just comparing distances until you find two of the furthest ones that match pretty close. And you just rotate it to them. So 1 to 4, 300. And this is important. When you finally figured out which points that you're going to hold, 104 is the same as 100 to 104 or whatever. So when you finally figure out which points you want to hold, you want to inverse to them again, 1 to 4, and you want to write down what the bearing is. I made it simple for the tutorial, but this, will vary. So 1 to 4, and that matches 100 to 104, right? No, 100 to 103 is what it matches. Doesn't all matter since they're a straight line, but if they weren't, it would matter. So 100 to 103. That's also 90 degrees. Now we've figured out that we want to move point number 1 down here to point number 100, and then take ours up here and rotate them around until it matches this line from 100 to 103. So to do that, you go into Cogo, adjust transformations. And you can actually scale it if you should never have to do that. So just rotate and translate. Next. So here it's asking for your rotation angle. There's different methods, to this. You could do just one single rotation. The one you always want to do usually is 2 azimuth. And this is where it comes important that you wrote down the bearing from 1 to 4 and 100 to 103. So the origin point is point number 1. That is where our coordinates start. Our coordinates start at 100, or at 1. So the first azimuth is going to be 1 to 4, which we've already decided is 90. Second azimuth is going to be 100 to 103, which we've already wrote down. It's also 90. Normally this would have a rotation that'd be different. So you hit next, and then you can translate. And that's actually going to take point number 1 It's going to pull it all the way down here to point number 100. So we want to take point number 1 and move it to our calculated points. Right here is how you do the range of what numbers you want to move. You don't want to move all of them because that would make absolutely no sense. You only want to move yours, the points that you've shot. So you can add, and this is why you want to split it into ranges. You can, add a single point name, and you can sit there and add a bunch of them or whatever. You could add points within a radius of a point or whatever. Points by name range. That's how you do it. We'll do 1 to 5. And then hit add. Now it's made a list of all the ones that it is going to move. Accept, and you say apply the defined transformations. Yes. Transformed 5 points. As you can see, now all of our points are there. And that is how you translate and rotate in the Trimble.